Hi guys. I'm here to speak with you about how you can create scalable and highly available applications using the RavenDB document database. But first, let me present myself. That's the everyday me. I'm a software developer, and I come like here to work, actually with a bird. So my public speaking level is something like -100. So I'm not going to show you any sales pitches or stuff like that. I'm going to show you things that I know how to do, which is coding, which is the live demonstration. And let's get going. RavenDB. RavenDB, whoever's seen our rollups at the outside, it's a document database. Document database actually doesn't store Word documents or PDFs. It stores JSON objects. But I'm not going to talk to you about how you model data in document databases and how you denormalize stuff. I'm just going to show you that. I'm going to fire a RavenDB instance, and another one for later. Actually, I don't know if you can see, it actually listens to the 8080 port. It means that its API is a REST API, and on base of this API, we built a management studio. And that's how it looks. Right? Here we go. I have this message because I'm running on Windows 7, and there is no WebSockets in Windows 7. So I'll go ahead and create a sample database. Good. And create a new document. Now, I've been thinking what I want to present, and actually, what I like the most is my fiancé and my 3 cats. So I have 3 cats, and so let's start from cats. I'll create an animals document. I'll create my first cat, whose name is Choco. His weight is 8 kilograms. He's pretty chubby. And his owners are me and my fiancé, which are Maxim and Gilly. And that's it. We have our first document. As you see, it's actually a JSON object. That's what it is. Now, Choco has a stepbrother. His name is Betel. He's a bit fitter. He weighs 6 kilograms. And we have a baby cat, whose name is Vanilla. And she's really thin. She's something like 4, I think. OK, that's it. What we have now is, until now, is some kind of key value store of keys, as you've seen, animals 1, 2, 3, and the JSON documents. But for a database, that's not enough. We actually want to query the data, aren't we? And that's what I'm going to show you now. I'm just going to choose the dynamic index. And I'm going to look for my cat, Choco. Let's see. Yeah. One moment. That didn't happen in the rehearsals. Yeah. I'm going to give it a try for a couple few seconds, and I'll continue. If we can't go on. I'm going to try that. Well, never mind it. There's some unexpected condition. So I'll keep going. What I wanted to show you is how RavenDB actually queries documents, how according to any field that you enter, it knows how to process all the documents, and actually, on the way, index them. So for the next time, the operation will be much, much faster. So that was about RavenDB in general. Sorry about the little technical problem. I hope we won't experience it anymore. But I came to talk to you about first about high availability. How in RavenDB we gain high availability. We gain it using replication. I don't know if anyone has heard about replication, how it works. I'll explain you. We have two different independent instances of the database. Each one of them has its own storage and its own application. They communicate between each other, and they synchronize each other. Now, let me show you. Just go ahead and use my demo helper. It's a little application that does a couple of things that I just didn't want to do during the conversation with you, including creating new databases and configuring them. But let's look at that. At the 8080 database, we see the zoo database appearing. Actually, all the demonstration has the animals theme. And let's have a look. It's actually pretty empty, but it has a replication configuration. And that's how it looks, and that's how a typical system administrator should configure it. And very, very similar thing is in the 8081. Instance. Here you go. As you can see, again, it's very, very simple. We state the URL, destination database, and that's it. It works. How well I'm going to prove it to you? Every time that I press a button, from now on, a new document will be stored on the 8080 database. Afterwards, the 8080 database will copy the new document to the 8081 instance. So here we go. And we can see that we have big amount of animals in the 8080 and the 8081 databases, and actually, they're synchronized. But what you've seen now is only the replication. In best case, it can be used for very quick and live backup. But I came to talk to you about the availability, the NTI. So in order to demonstrate availability, I have to make something unavailable. So let me just go ahead and kill that 8080 instance. And it's not with us anymore. I'll reload the page. Nothing, no one answers. I reload the page here. 8081 is still alive. And I'm going to go back to my demo app and press the key again. OK. Actually, you see that it took a bit more time. I'll explain why. What the client API did, it actually accessed the 8080 instance once. It didn't answer. It said, OK, maybe it's some kind of a network failure. Let's try again. It tries again. It fails again. For the third time, he tells itself, OK, let's try the replica, the other guy. He does it, and the operation is completed. From now on, it continues talking with the other replica, and everything is going as smoothly as before. Now, what will happen if we'll fire again the 8080 database? Now, what would you expect to happen now? I guess that you would expect that you'll have to ask the system administrator to copy the files, all the data files from the 8081 instance to the 8080, and to ask the databases keep going. Actually, what happens in RavenDB is that the 8080 database, when it comes alive, it asks the 8081 database, yo fellow, what changed since last time we talked? And it tells him, you know what? I actually received a bunch of new documents. And here we go. We have 32 documents in the 8080 database, and the same amount in the 8081. It means that after the crash, after the system administrator got the machine alive, we just keep going. Now, how did we do it? Actually, the syntax that we used, and here I show you the .NET Client API version. And also, we have a Java Client API version, and this version we can show you at our booth. We just open a new session. It actually looks a bit like an ORM, like the Hibernate ORM. We ask it to store a new animal, save changes, and that's it. We're good to go. So you must be saying to yourself, OK, so maybe the connection to the database is more complex, and we have to do more work. And actually, you don't. That's all you have to do in order to configure the connection to the cluster. You state the URL, you state the database, you're good to go. What happens in the client API, it asks the 8080 database, well, who is your replicas? And it answers him. And the client API knows what his behavior should be from now on. So all the work is done by the guys who configure the database. And as you've seen before, it's actually pretty easy. then we would have a problem. But this moment is actually the first moment when you fire up the whole environment. When you do that, in most cases, I think that you're sure that everything is up. The problems happens after after you go to production. There's a electricity crash or anything like that. Actually, there's a way that you can also configure in the client side this structure. And in this case, we actually will be able to work it out. Now, next point that I wanted to talk to you about is load balancing. You see, what we've done now is, in order to gain high availability, we made you buy 2 machines, 2 RavenDB instances, and you say, wow, now I pay so much, I paid so much money for the hardware, and I pay for the licensing, and all I get is a failover for any day. Actually, we allow you to use this cluster for load balancing. This way, in regular conditions, we're load balanced, and whereas there's a crash, we just keep going, and yes, there will be a bit more stress on the surviving database. Now, that said, let's imagine the next situation. Only for this slide, I'm going to leave the animals team. I'm going to go to the banking team. Imagine that you have a bank and you have an account, a corporate account, and you gave away your cards to all your employees, and all they do all day long is going to ATMs and taking money out of your account. And there's a specific moment in which 2 different users went to the ATM and withdrawn $100. What will happen now? What will be the situation of the account? Actually, RavenDB knows how to spot these situations, and it will help you to resolve this conflict. And that's what the next demonstration is about. The demonstration itself will be in the animals team, just in order to make it simpler. What's going to happen now is that the zoo database is going to be recreated. And every time I press a button, a conflict will be created, because the same animal will be created in both databases, and RavenDB will have to figure out what to do. And let's have a look. Okay. So I hope that you see that we have here animals 5. Underneath it, we have animals 5 conflicts, some good, and animals 5 conflicts, some other good. Let's see that one. We see that we have name dog number 5A, weight 0, species dog, and the other one is the name just ends with a B. So let's look at the animals 5 document, and what we see here. We see here actually that RavenDB processed both versions of the document and find the conflicting field. And now it tells you, well, I've seen this field with value dogs number 5A. And I've seen this field with value dogs number 5B. What do you want to do? And let me answer him. What I want to do is that I want the name to be dogs number 5C. And that is it. What we're going to see now is that the other two documents that represented the conflicts are gone because the conflict is resolved. We have the final version, docs number 5C, and in the 8081 database, animals 5 already has the final version. Now, some of you will say, OK, you found my problem, but you didn't solve it. And actually, I believe in cases where there could be hundreds of conflicts like that in a minute, this solution won't work for you. Or else you'll have to have hundreds of workers just looking for conflicts. That's why we actually have the ability to allow you to have your own conflict resolution logic, so it will just keep going as you want. But there's another case. There's a case that you don't care. You just don't care. You say, OK, whatever, just let me keep working and just figure it out. For this case, if we'll go back to the replication configuration, we can see that we have this conflict resolution field. For now, it's none. None means that we do nothing. We could choose one of these other options. I'll choose resolve to latest, which means that the latest wins. And I'll do it on the other replica too. Here we go. From now on, I can create as many documents as I want, and all the conflicts will be resolved by himself. As you see, we have no other conflict indications. That was easy, right? Pretty easy. Considering that all you have to do is enter the web UI and change some configs. Now, what did we have until now? We've seen that we can configure replication between two servers in a minute. We've seen that we fail over without any code written on the client side by you. It's all the code is already written by us in our pretty rich client API. You see that we know how to resolve conflicts and to load balance. Now, if that's not enough, let's talk about scalability. Actually, in RavenDB, we get scalability by sharding. We actually allow the users to divide the dataset into several machines. This way, the load will be divided between several machines of RavenDB. And this leads to my third demonstration. OK. Now, let me just explain you the setup because this time it's a bit more complicated. OK, what we have now is that we have dog zoo, cat zoo replica in the 8080, and dog zoo replica and cat zoo in the 8081. As you see, it's kind of crisscross. So each database has its main purpose and has the fallback for the other shard. This way, our cluster, in case that one of the parts of the clusters crashes, it actually can continue going on and on and on. And let me demonstrate it to you. And I'm just pressing the button. I just keep generating random animals. And let's have a look. We have 31. Wait. The number isn't there. We have 63 animals in the dog zoo in the 8080. We have 64 animals in the cat zoo. And the same situation is in the 8081, as you can see. Now, you would say maybe this configuration will require from you to really lots of job, and actually it isn't. That's all it needed to configure in the client-side connection to this cluster. We defined a dog shard for the dog value of a species that whose default database is dog zoo, and the URL is the 8080 instance. And we have the cat, whose main URL is the 8081 instance, and the default database is cat zoo. And after that, we define the sharding strategy, and we're good to go. And actually, its usage is as simple as we've seen before. We just say we create a new session, we ask it to store, and the client API, according to all the configuration we've seen before, knows to which one of the server to send the data. Now, just in order for the demonstration to be whole, I'd like to shut down one of the instances and see what happens. Actually, after the first first delay that we've seen in the replication scenario, we just keep going. We can look at the 8081 database and see that it keeps updating. And as you can see, the numbers just update. Again, in this scenario also, we fire again the 8080 instance. And it is synchronized. And in this time, we can kill the other instance also and have the same results. Okay. as you can see, here also we just keep going. And if we'll fire again the 8081 instance, it will be just fine. Now, I see that I spoke a bit fast. So I'd like to show you a couple of more things that we can do with RavenDB in order just not to waste the time. So I'll go ahead and go to the 8080 database and create a new Northwind database. Now it's empty, and actually a nice thing that we have is that we allow to create sample data in order just to have something to play with. And here we have it. It's nice. And let's have a look at our indexes. We actually index data according to lots of things like totals of the orders, but we have this index, which has only 89 entries. And this index is actually a MapReduce index. Now, what happened here is that RavenDB allows to do a pre-computed MapReduce, which means that, unlike in other cases, you have to go through all the documents for each query and do the MapReduce operation. It does it in its free time, and then it stores it in a Lucene index. This way, this record that you see of the company count and total can be queried. And, well, yeah, unfortunately, again, I have the same error. Try to overcome it. No. Okay. Let's see what else I'd like to show you. Well, okay. I'll show you the patching API. Actually, we allow you to send a Java code that will process a whole very, very big amount of documents on the server side. So you won't need to, to query a document, to change it, and to send it back. Just let the database do the whole thing. Just for example, I'm going to pick a collection, let's say a company, and to ask it well, just create a new field, and actually in wait, here we go. in pretty simple manner, we can achieve it. As you can see, every new company that we created, we have it with this dummy field. Okay. Any questions? Yes.
How different is this from MongoDB? Because MongoDB is also a document-oriented data store, and I see that you do exactly like MongoDB.
Yeah.
What is the difference?
First, it's about how we look at transactions. MongoDB is a good, fast database. And as far as I know, its transactions ends up with the data being saved to the RAM. And its optimization is to choosing by itself the right time to take all the changes that need to be saved and save it to the storage. We take the time and we wait until the data is actually in the database. So in case that there's a system breakdown, something like that, we know that the storage has the data. That's first. Second, how we look at the queries. Whoever uses MongoDB, unless it's a very, very basic case, would like to actually integrate it with some search engine. He could choose to implement it by himself, to implement it on base of the same Lucene, or choose engines like Solar or Elasticsearch, which are also based on Lucene, which is just very smart technology, in order to query. In RavenDB, you're just ready to go. You don't have to do these integrations. The Lucene is integrated, Lucene.net. It's a port to .NET of Lucene. It's integrated inside RavenDB. So it's all about simplicity. As you've seen, the syntax is very ORM-like. You just can start working and get the results very, very fast.
So can you show me a query, like if you want to write a query?
Sure. Because I don't have a Wi-Fi connection here, I'll just use the demo code, because otherwise I'll have to download the client from Nugget, and it will take time. No, I don't want a preview. The license is over. let's say that we have some class person as here we go. From yeah, that's it. Sorry about the delay.
So if you don't have an interactive shell kind of thing to query, you have to write a program every time to query the database.
Yeah, what do you mean interactive shell?
You have a Mongo shell if it's MongoDB.
Okay.
So you don't have something similar to it, like with MongoDB it will be a one-line command, like to get a data from collection.
That's the one-line command, but don't you have code that you have to write in order to connect to the database, to authenticate?
No. Like
No?
if you want to just send it to MongoDB and do it, you can just do it through a shell, like not through a regular program. You have APIs to do that. Command line? Yeah, command line.
Yeah, actually we have the REST API, in which you can do the same. Actually, the same query that doesn't return values. Actually, that's how the request looks. So yes, if you want to be very, very, low-level, hardcore, REST request user, you can do it. All the client API is based on the REST API.
I have two questions. One, so does that mean that through the REST API is the only way I can know where all the data is, in a sense? Like the dashboard shows that you have database one here, and then 8081 had the replica of that database that was doing sharding and had 100 of these. Through the REST API is the only way I can know all the data, where copies of each of the database are, where the data sets are.
Through the REST API, you'll have to, yes, you'll have to remember it by yourself. The client API remembers it. The client through the REST API, you'll have to implement it all. The sharding logics actually occurs in the client side. So you'll have to implement it all by yourself. But again, we have the .NET client and the Java client. So in most cases, it will be enough and it will be good. Also, we have customers who chose to use the REST API and they're happy with it.
Okay. And then the other question was on design for architecture.
Mm-hmm.
With the conflict resolution, what you mentioned that clients can have the control on resolving their own conflicts. Is that TTL based, or my question is if I wanted to use this in a fast-paced environment, what type of control do I have to prevent conflicts?
Yeah, you would query the database, have the information that there's a conflict, and use a specific API to receive all the possible resolutions, and choose one or create one of your own. Thank you very much for listening.